A car travels at 60 miles per hour for 2.5 hours. How far does it go? That's 60 times 2.5 is 150 miles. That was easy. But what if you only knew the distance and the time instead? What if multiple cars were involved? How do you always figure out the missing number? That's why we are going to use one equation for all of these problems. D equals RT. D equals RT is a simple equation that states distance equals rate times time. When we're given two of distance, rate, and time, we can always solve for the other one by manipulating the equation around. So let's do one quick example just using the equation before we get into something you might see on the math counts or AMCs. A train travels 180 miles in 3 hours. What is its speed? So in this case, we know that the distance is 180 and that the time is 3. We're trying to figure out the rate or the speed. So we just substitute these values into the equation we already know. So 180 equals 3 times r, so r equals 60. So before we move on, I want to warn you guys of some variations. So when we're working with these so-called rate problems, we need to also be aware that there are variations. They don't always have to involve distances or vehicles, and there's just a bunch of other sort of things that they can throw at you. So for example, here's a rate problem that you might see. 1 mole digs 1 hole in 6 hours. How many holes do 3 moles dig in 2 hours? So for this, we use an equation known as W equals RTN, and that just stands for work done equals rate times time times number of men. And so now let's just use this equation to solve this problem. So we know that the work done is 1 hole, and we don't know the rate, so we're going to leave it as it is. And then we know the time is 6 hours, and we know the number of men is 1. So solving for r, we get r equals 1 over 6. And then we're just going to use this to solve for what the question is actually asking for. So the question is asking for how many holes. We don't know that yet. So we don't know the work done. So we know W equals, we know the rate because we just figured it out. And then we have the time as 2 hours. And the number of men is 3 moles. And so we just get W equals 1. So that's our answer. The 3 moles will dig 1 hole in 2 hours. Okay, so now we have a hold of how exactly we use the equation, and we're aware of what variations we might see. But contest problems often throw a lot of other things at us, which makes it hard to spot exactly how to use the D equals RT equation. So we'll get started with a couple of examples and then look at the key idea to use when solving these problems that will make it a lot easier. And then we'll end with some more examples. And also, I'd like to mention that I have a free handout that you can use, which has a bunch of problems on it that you can do for practice for getting better at rates. And that's just linked in the description, and it's free. So I would encourage you guys to check that out after this video. So let's move on now. So here's our first problem. Mr. Early Bird leaves his house for work at exactly 8 a.m. every morning. When he averages 40 miles per hour, he arrives at his workplace 3 minutes late. When he averages 60 miles per hour, he arrives 3 minutes early. At what average speed in miles per hour should Mr. Early Bird drive to arrive at his workplace precisely on time? And this is from the AMC 10. So I'll let you guys think about it for a second. Okay, so there's a lot of stuff that we just don't know in this question, but we're still going to be able to figure it out by having two different equations. So we have two different rates, so that's like sort of our clue to know that there's going to be two different equations. We don't know the distance from his house to work, so we're going to leave that as D. And we're going to set that equal to 40 times some amount of time. So in this problem, they don't really tell us how much time it will take for him to go from his house to his workplace. So if he drives at the correct rate that he needs to go at to arrive at his workplace, then let's say the time that it takes for that is just T. So T is equal to when he's on time. So we know that when he drives at 40 miles per hour, he arrives at his workplace 3 minutes late. So something that we really need to notice here, this is important or we're going to get this problem wrong, is that we're given the rate in miles per hour, not miles per minute, but the time is in minutes. So we need to convert 3 minutes to what fraction of an hour it is. So since there's 60 minutes in an hour, we can just say 3 over 60 is number of hours, or simplify it to 1 over 20 hours. That's how late he's going to be. So we say T plus 1 over 20 because we're going that much later. But we also know that the distance is equal to 60 times T minus 1 over 20 because he's 3 minutes early. And we use the same variable D because the distance between his house and his work isn't going to change based on the rate. It's going to stay the same. And so now we're going to set these two equations equal to each other because they're both equal. So we're going to set this thing over here and this thing over here equal to each other. So, and again, we're doing this because they're both equal to D, so they must be equal to each other. So 40T plus 1 over 20 equals 60 times T minus 1 over 20. So now we just have to solve this. So let's just solve for T. So 40T plus 2 equals 60T minus 3. Subtract 40T from both sides to get 2 equals 20T minus 3. And now add 3 to both sides to get 5 equals 20T. And then divide by 20. So T will be equal to 1/4. So that's 1/4 of an hour. And so let's just substitute this into one of these equations, either this or this, and that will help us understand what the distance is. So let's just do it into the first one. So 40 times 1 over 4 plus 1 over 20 is equal to be the distance. And so we just need to compute this. So 1 over 4 plus 1 over 20 is going to be equal to 5 over 20 plus 1 over 20, which is equal to 6 over 20, and that's equal to 3 over 10. So now we can put this back there. So 40 times 3 over 10 is going to be equal to our distance. And that's just 12. So, but that's not what we want to know. We want to know the rate that he needs to drive at to be on time. So we know the distance, we know the time, we just need the rate. So that's what we're going to solve for. So we did 12 times 4 equals r because we're dividing by 1/4 on both sides. And so r equals 48. And 48 is our final answer. So I'll give you guys a minute to look at that a little bit. But basically, the key process in this problem was just to create two different equations, solve those equations, and then use that variable, substitute into multiple equations, and then we get our final answer. So here's our second problem. A cart rolls down a hill traveling 5 inches in the first second and accelerating so that during each successive 1 second time interval, it travels 7 inches more than during the previous 1 second interval. The cart takes 30 seconds to reach the bottom of the hill. How far in inches does it travel? So we know that first it travels 5 inches. Then it travels 5 plus 7 inches. Then it travels 5 plus 7 plus 7 inches. And note that this can just be 5 plus 2 times 7 inches. And then it goes 5 plus 7 plus 7 plus 7. And we keep going on like that. And this could be 5 plus 3 times 7. So the important thing to notice here is that this is forming an arithmetic series. And if you remember what an arithmetic series is, it's just when there's a sequence of numbers like this, and you're adding the same difference each time. In this case, we're adding 7 each time. So this is an arithmetic series. We need to know the sum of this series. And for this, there's a neat formula that's important to keep in mind when doing competitive math. And that's n times a sub 1 plus a sub n divided by 2. And that's for finding the sum of an arithmetic series with n terms first term a sub 1 and last term a sub n. So we're just going to use this formula. Before we can use this, we want to know what the last term is, and that's going to be the 30th term in this sequence. The 30th term is what we're supposed to calculate. It would be really tedious to just calculate all of this up until then. So what we're going to do is use another neat trick. So we just need to know the first term. And then the 30th term is going to have 7 added to that 29 times. Because there's sort of 29 of these pluses in between to get to the 30th term. So we can compute that. And that's going to be 208. So we know that. And so now we can use our expression over here. So the number of terms is 30. The first term is 5. The last term is 208. And we divide this by 2. We can cross this off. So we need to know 15 times 213. And that's going to be 3,195. And that's our final answer. As you've seen in the 2 example problems we did, rate problems are rarely straightforward in contests. So here's some tips that will help you to solve these problems. First of all, rate problems are often combined with other topics to make the overall problem harder in math contests. So always be on the lookout for other topics in the problem. For example, in the last problem, we had to use arithmetic sequences. Next, some problems may ask you to find the average speed. a common mistake in this is something that a lot of people do, and it's to assume that you just have to take the average of all the speeds. But the average speed is not always the average of all the speeds. The average speed should always be calculated as total distance over total time. Third, you need to be careful with units, because we saw in this problem over here that we had to change this in minutes into hours. So that's always just something that they try to sneak in there. And rate problems sometimes also involve adding and subtracting rates and creating multiple equations. So sometimes d equals rt is just one step of the problem. Now on to our next problem. On Monday, a worker began painting a fence at 8 a.m. At 10 a.m., 2 more workers showed up and helped the first worker paint. The 3 workers finished the job at 11:30 a.m. On Tuesday, the first worker began painting an identical fence at 8 a.m. The other 2 workers showed up earlier this time, and the job was finished at 10:54 a.m. All 3 workers paint at the same constant rate. How many minutes did the first worker paint alone on Tuesday? And this is for math counts. So, we know that we're going to find something in minutes. So let's just start using minutes from the beginning of the problem. So first, we want to use the first part of this scenario, which is what happened on Monday. So, in the beginning, there was 2 hours for... So first, though, what I want to say is that they were at a constant rate. So let the constant rate be equal to r. And so when it was only 1 worker for the first 2 hours, the amount of distance that he painted on the fence would be his rate times 2 hours, which is 120 minutes. We're keeping everything in minutes because at the end we want to use minutes, so we're just going to continue that from here. And then the 3 workers came, or the 2 workers came later, so the 3 workers would have a combined rate of r plus r plus r, or 3r, and the distance that they would have is 3r times 1 hour and 30 minutes, because between 10 and 11:30 there's 1 hour and 30 minutes, which is 90. So this is 120r, this is 270r. So in total we can express the distance of the fence, which I'm saying distance over here, but actually the length is 390r. And let me label that over here. Length of fence. So now we move on to Tuesday. The first worker is painting an identical fence, so it's going to be the same length. And we know that his rate is going to be r. So let's set, so the distance is 390r. So that's going to be over here in the, for distance, right? And then we're going to want to use, so for some amount of time, the first worker is going to be painting by himself, and we don't know how much time that is. So the time that he's painting by himself is going to be x. So x equals time 1 worker is painting. So we're going to have x times r, because that's 1 worker's rate. But then there's going to be another portion of this time period where all 3 of them are working. And this time period, the total time period, is the time between 8 a.m. and 10:54 a.m. That's 2 hours, 54 minutes, or 174 minutes. Again, notice how we're keeping everything in minutes. So since the first worker is painting alone for X amount of minutes, all three of them will be painting together for 174 minus X minutes times R, or times 3R, because all of them are together. Now we can just divide this whole thing by R. And we just continue solving for X. So X equals 66. That's our final answer. Okay, so that was our last example problem for today. But as always, if you want to get really good at this topic and feel more confident, you need to do practice problems. So please check out my free handout with practice problems and solutions linked in the description. If you have any questions or topics you want me to cover in my next video, comment below. And if you enjoyed this video, make sure to like and subscribe. Thanks everyone, and see you next time.